most fearsome fighting team. Right, so this is everything you need to know about trigonometry, so you can understand how to do SI numbers, fractions, Bob Marshall equations, and you do transposition. There's a couple more things that you need to be able to do to follow these videos, to follow engineering videos, or science videos, or maths videos. The next thing we're going to do is trigonometry, and then we're going to look at matrices, because we need to know both of those to be able to carry on. So today we're going to look at all you need to know about trigonometry. For trigonometry, there's one basic word you must remember, and that word is SOHCAHTOA. Now, a lot of people have different ways of remembering it, but if you just remember the word SOHCAHTOA, learn how to spell it, and then learn how to break it down, you've got a good start. So let's first of all spell the word. SOHCAHTOA. There you go, that's SOHCAHTOA. Now that word breaks up into three sections. Let's have a look at that. We've got SO, CA, and TOA. And when we take those three individual bits, they break up again, like this. Sine theta is equal to opposite over hypotenuse. CA, cos theta is equal to adjacent over hypotenuse, and TOA, tan theta, is equal to opposite over adjacent. Now, what are we talking about with opposite, adjacent, and hypotenuse? Now, you recognise that sine, cos, and tan are little buttons that you got on your calculator. The rest of it all relates to a triangle, a right angle triangle specifically, like this. Our right angle is there. Our theta, our angle, is here. Then we got the hypotenuse, which is the longest side. Opposite is this side, which is opposite to the angle. And adjacent just means next to. Right, adjacent to, it's next to the angle. So there's our triangle. That's how they all fit together. Make sure you can break that down just like that for anybody who ever asks it of you. So what I'll do next is I'll take one of them, I'll probably take sine, and we'll have a look at what else we can do with this. We've got sine, opposite equals sine theta equals opposite over hypotenuse. So that's sine of the angle of a right angle triangle is equal to the opposite length of the opposite side of the triangle divided by the hypotenuse, the longest side of the right angle triangle. Now we can rearrange this for any triangle. Let's have a look at this. So we've got this. We got the hypotenuse, we got the opposite. We don't know what the adjacent is. We don't need to know in this case. So what we can do, in order to find, if we know the angle theta, in order to find the length of the opposite side, all we need to do is rearrange this equation. So we got the hypotenuse times sine of the angle is equal to the length of the opposite side. It's just transposition. We've learned transposition in our basic maths, so you should be able to do that anytime you want it. What else can we do with this? We can find the angle if we know the length of the opposite side and we know the length of the hypotenuse. Then we can find the angle. How can we do that? Right, well, let's have a look. Okay, so we got sine theta equals opposite over hypotenuse. So if we divide this side by sine, and then we have to divide this side by sine as well. That'll cancel with that. And we're left with this. Theta equals opposite over hypotenuse over sine. Now let's break this up. Do you remember fractions? We can break this up in this way. We can say theta is equal to 1 over sine times the opposite over the hypotenuse. Now if you remember your multiplying fractions, 1 times the opposite, sine times hypotenuse, we've got exactly the same thing as we got on this side. So here's a special little thing for you. See this? Now, there's something called laws of indices. This, technically speaking, is sine to the power of 1. And what we can do with this, right, if you think about 1 over 10, to make this simple, 1 over 10 is equal to 10 to the power of negative 1. Notice any number is to the power of 1. So 1 over 10 is the same as 1 over 10 to the power of 1. What we can do is we can bring 10 up here and we can get rid of the fraction if we change the sign of the power from positive to negative. And you put this in your calculator, you can check, divide 1 by 10 and then put in your calculator 10 to the power of negative 1. You'll get the same number. We can do the same thing with this. We can bring sine to the 1 up to the top and we get sine to the power of negative 1 times the opposite over the hypotenuse, and we get the angle. That's why you've got this special button on your calculator. So here we go. Now we've got, just from doing a basic bit of transposition, understanding a bit of fractions, we can now find from sine, we can find the hypotenuse, we can find the opposite side, and we can find the angle given another two parts of the triangle. We can break down sine, cosine, or tangent in exactly the same way. So what are we going to use this for, right? Now obviously it's going to be related to triangles, but in engineering it also relates to any machine that rotates. If we've got a right angled triangle, like this, there's our theta. We say that the hypotenuse is equal to 1. Now what happens when we do that? Essentially, this hypotenuse can be the arm or the radius of a circle with a radius of 1, a unit circle. So as this arm rotates like this, we can find, using sine equals sine theta equals opposite over hypotenuse. If the hypotenuse is equal to 1, then sine of the angle is always going to tell us the length of the opposite side. This bit. At any position in this unit circle. If the hypotenuse, or if the magnitude of any signal is more than 1, or the radius of circle is more than 1, all we need to do is move this over here, and we've got the same answer. We've got the length of our opposite side just by multiplying the hypotenuse, or by scaling up the size of this circle. So in engineering, this is vastly important. It's hugely important across the board, and we need to first practice SOHCAHTOA, practice remembering that word and breaking it down. From there, we'll have a look at some more videos. Thanks for watching.